Good morning, everyone. My name is Philipp Rupp from Wärmepumpen, and I will be happily presenting my presentation, geoAir Soil Regeneration through Exhaust and Outer Air, which is our newest innovation from WIDA. But first of all, I would like to say a few words about Wärmepumpen. We built heat pumps since 45 years. We are based in Austria. We are a small production company, around 50 employees. We produce everything in-house, so we are a real made-in-Austria product. This is our main heat pump called Valtrona, and we are located in Vorarlberg at the Lake of Constance, at the Bodensee, right in between Germany and Switzerland. First, I want to present the main results of the geoAir before talking about the innovation itself. So we implemented the geoAir at a big project in Austria, in Vorarlberg, where initially a geothermal heat pump was planned, and the initial planning cost just for the probes itself were 150,000 euros. And through the use of the geoAir, the investment cost for the geothermal source could be reduced by 60,000 euros in this case. And the high cost for the source is usually a problem for the geothermal heat pumps for larger use. The geoAir is a central ventilation system and combines the best of two worlds from ventilation and geothermal energy. On the right, you see the ground source heat pump, our Valtrona, and this can be done with any geothermal source, so probes, trench collectors, source collectors, anything you like. And a part of the brine inside of the collector is going through the ventilation system itself. So on the left side, you see the geoAir, the actual ventilation system. And the geoAir has 3 heat exchangers. The first one, number 3, is the actual air-to-air heat exchanger, which is quite standard in ventilation systems. And it regenerates the heat and the humidity from the exhaust air. But where the innovation comes in is actually the heat exchangers 1 and 2. So the first one is a brine to air heat exchanger, and the goal is to win energy from the outgoing air and store it in the source. You can imagine that in winter, the source temperature is usually between 0 and 5 degrees, and the outgoing air, the temperature is around 10 to 15 degrees. So there's quite a big delta T throughout the winter, and this results in higher temperature throughout the winter, and this enables regeneration of the heat of the geothermal source during heating period. The second heat exchanger is a brine to air heat exchanger as well, and it goes from the outside air on the brine. And whenever in winter the outside air is warmer than the source temperature, it also rises the source temperature, and we are able to store energy in the source itself. But also in winter, when the outside air is cooler than the brine itself, the brine actually heats up the outside air, and freezing will be prevented in the third heat exchanger, in the air-to-air heat exchanger, and the inlet air will also be warmed. So this is more a comfort, an improvement of comfort, because some people argue that on cold days, the inlet air is also too cold. And the geoAir also doesn't work with additional heating elements, so also the efficiency is improved. And in summer, Some people may argue that it's also when the outside air is too hot, right? Then the inlet air also becomes too hot. And in summer, the brine actually cools down the outside air, which is part of a passive cooling. You can imagine it like that. And it's also more comfortable inlet air temperatures. So this was our first calculations, how much we can actually regenerate from the heating energy we take from the source. In orange, you see the regenerative power of the geoAir, so how much these two heat exchangers actually can regenerate during the heating period. And you can see, and the blue line is the cooling capacity, so how much power the heat pump actually takes from the source. And you can see that at around 6 degrees Celsius outside temperature, these two lines cross. So that means whenever it's warmer than 6 degrees outside, we actually regenerate more power, we actually regenerate more energy into the source than we take out of it. And when we are, for example, at 0 degrees, we only take out 50% of the energy if no geoAir is used. And this is all during heating period. These calculations led us to our first project. So this is our pilot project. It's a building in Lower Austria. It's 9 flats. This is how it looks. This is the ventilation system and our heat pump. And the field test actually shows the following. So this is data from the pilot project from the first winter. And we compare two data lines here. The first one is the source temperature. You can see in orange with the geoAir. And you can see that the source temperature actually reaches its minimum in January, right? So after January, we with the geoAir puts more energy into the ground than it takes out, and we have an active regeneration from January. And usually the minimum source temperature is reached after winter, so March, April, and then it goes up when the heating stops. And the blue line is also from the same building. It's actually the cold water temperature, which shows that the minimum of the natural source without regeneration is actually reached in March and rises in April. So this shows the regeneration works sufficiently, and we can restore the source. We can regenerate the source well enough. This proves the geoAir works. This is what so it led us to the development of a prototype as a serial product. This is how it looks for smaller buildings for up to 300 cubic meters per hour. You can see the two heat exchangers. This first one is on top side, it's the outside air to brine, and on the bottom side, it's the brine to the outgoing air. In the middle, you can see the air-to-air heat exchanger, and on the top, it's filters. And on the back side, you see the inlets for the brine. And you might argue now, okay, this might work in theory, but this might get complicated in dimensioning, because you have the ventilation system, you have the source and the heat pump, and they all have to work together at the end of the day. This is what led us to developing our own in-house simulation tool to simulate with historical weather data on an hourly basis how much the geoAir actually regenerates at a given location. So you tell it the heating capacity, the cooling capacity, the location, the length, how many years you want to simulate, and the airflow. And this is a slice of a simulation of the results, and it shows the average energy for cooling and the average regeneration energy per month over the last 10 years in this case. And you see the blue bars are the cooling energy, so actually what the heat pumps takes from the source, and the orange bars are the regenerative energy from the geoAir, so the energy which will be restored during heating period. You can see the orange bars are pretty low in October and November. That's because the source temperature is still very high after summer, 10 to 15 degrees. And so the delta T compared to the outside air and the exhaust air is not very large. So basically there's no generation during this period. But when the source gets cold, starting in December, you can see the cooling energy rises, but as well as the regenerative energy. And even in March, in this case, we restore more energy than we actually take out of it. So, and if you want to compare this now, how much we can actually restore during the heating period, in this case, so if you sum up all the orange bars from the previous plot and compare them to the blue bars, so the regeneration compared to the regeneration energy compared to the cooling energy from the source, we end up restoring almost 60% of energy during the heating period on average over the last 10 years. Now the burning question is how much smaller can we actually build the source? And there I would like to say a bit more about the current project we are, which is actually now finished. It just finished in summer this year. This is the one of the 3 buildings. It's 2,500 square meters. 75% is for residential use and 25% is for commercial use. This is in beautiful Vorarlberg in the Bregenzer Wald. And as I mentioned in the beginnings, initially it was planned to only use probes. So initially the plan was to build 1,550 meters of probes. But with the use of geoAir, it was able to switch to a combination of trench collectors. So it's 200 meters of trench collectors around the building, around the buildings, and 3 probes with 80 meters length. And in this case, the construction cost for the source could be reduced from 140,000 euros to just below 80,000 euros, which resulted in a cost reduction of 42% just for the cost, just for the source. Not only does it offer cost reduction for the construction cost of the source, but also since we can fully regenerate the probes or any other source, it is also possible to construct probes in densely populated areas where cooling of the probes is no problem. So we can place probes in between probes where it might be not actually allowed to do so. And also, if you talk about trench collectors or surface collectors, we can also significantly reduce the space. So, as you might know, in densely populated areas, the use of space is very important, and this is also possible since we can regenerate the source during winter. And talking about trench collectors, this is also a current project of us, which was finished in winter last year. This is a renovation of an old house, and this was so with almost 6 kilowatt of heating capacity. This was done with just 27 meters of trench, and you can see the building. This is not a lot of space we need here. And I told you in the beginning, we actually build heat pumps and not ventilation systems. That is why we have a cooperation with Drechsel und Weiss. It's also a local ventilation and heat pump company from Vorarlberg. And they produce the ventilation system for us because they're an absolute expert in their field since many years now. And yes, they built the product for us, and we sell it. Okay, thank you for your attention. And I would like also to invite you to our booth. We are in 4A at stand 430, and we also have a geoAir device with us, so you're all happily invited to check it out and learn more about it. And if you have any questions, feel free to ask. Thank you.